But basically what she's working on is the fundamental nature of the self and of the mind. And then she does that from quite a number of vantage points, from philosophy of mind, metaphysics, cognitive science, applied ethics, and then also astrobiology and artificial intelligence. So wonderful contributor to this conference. So please join me in welcoming Susan Schneider.
Just to flip it on in the back.
Thank you for the kind introduction. I'm having such a good time at this conference. I think you're all set. I'm all set. Can you hear me? Yeah. I have such a loud voice normally, so wearing a mic is sort of dicey because I'm always afraid I'm going to just blast everybody with my loud voice. Okay, so unlike biological intelligence, notice that AI will not be the product of Darwinian evolution. It will instead be the product of intelligent design, but we, not some god, will be the designers. I find this quite humbling, frankly, because we're not terribly evolved. As the alien superintelligence puts it in the Carl Sagan film Contact, you're an interesting species, an interesting mix. You're capable of such beautiful dreams and such horrible nightmares. We harness the energy of the atom. We fly to the moon, yet all around us, racism and all kinds of injustice still abound. So the idea then of mind design strikes me as one that we need to be very, very careful about. For mind design doesn't just involve the creation of intelligent supercomputers or humanoid robots. Instead, it also involves altering the human mind. So let me introduce something that the historian Michael Best calls the Jetsons fallacy. Think about the show The Jetsons, which was a cartoon, or think about Star Wars. In these kinds of films and TV shows, AI is all around people, altering their lives. So there are all these cool robotic bells and whistles. But the humans themselves are unaltered by the AI technology. That's a problematic view of the future. Instead, AI won't just change the world. It will change us. Look already at the kind of work going on regarding neural prosthetics and enhancements. Think about the kind of projects that are even discussed at DARPA's webpage that involve the use of neural prosthetics for neuromodulation to improve the situation of those with things like post-traumatic stress disorder and Parkinson's disease. Elon Musk has recently founded a company called Neuralink, designed, as he says, to merge humans with machines. There's also a company called Kernel, a large company, and then famously, Ted Berger's artificial hippocampus, which is quite amazing, and is now in clinical trials in humans, having been successfully tested in non-human animals. These neural prosthetics are amazing, but as they move to the domain of enhancement, and they surely will, we have to really think hard about the future of the mind. Okay, so this being said, I'll just sum up by saying that evolution did the first wave of mind creation. Businesses may be doing the second wave. And should we leave mind design to companies like Facebook or Cambridge Analytica? Clearly, all stakeholders must be involved. But today, I'm not primarily going to talk about alterations to the human mind. I'm going to move on and focus my attention on the topic of machine consciousness. So what I want to do now is introduce an important philosophical problem called the problem of AI consciousness. This is the problem of whether the processing of an AI would feel a certain way from the inside, okay? And I'm going to discuss the import of the issue. I think it goes well beyond the familiar robo-rights issues. And then I'm going to talk about my work on testing for machine consciousness over at the Institute for Advanced Study. Okay, so this being said, let's start with a philosophical problem that may be familiar to some of you. How many of you have heard of the hard problem of consciousness? Okay, so it's worth going through, and it's fun to talk about. It's very upbeat, as opposed to the rest of my talk. Okay, so as cognitive science underscores, when we deliberate, hear music, see the rich hues of a sunset, and so on, there's information processing going on in the brain. But above and beyond the manipulation of data, there's a felt quality to our experience. Now, the hard problem asks, why doesn't all of our information processing happen in the dark? Why do we need to have inner experience? Why does it need to feel like anything? This is a challenging problem, to say the least. But the problem of AI consciousness is different, although obviously related. We're still thinking about that felt quality of experience, but we're not assuming that AI has it and asking why they do, why they need to be conscious. Instead, the problem is whether they're conscious at all. Okay, this being said, now let's move on to discuss why the issue of machine consciousness is important. There are a lot of reasons that I believe have been overlooked, and I talk about all of this in a new trade book coming out soon called Future Minds. So the first issue involves the nature of the mind itself. There's a classic problem in philosophy and religion, which is, does consciousness transcend the brain? So when we're asking about machine consciousness, in a sense, we're looking at this age-old question to try to see if consciousness can actually transcend the brain. Further, consciousness seems essential to selfhood and mindedness, right? I know as bioethicists, there are probably a lot of bioethicists in the room, or applied ethicists. You probably appreciate the role that sentience plays to ethical theory. So if we're investigating machine consciousness, we're asking which intelligent systems are selves or have minds. And this is of ethical import. Of course, there are also very familiar robo-rights issues. So there's the concern that we need to identify conscious AIs, should they exist, because it would be speciesist to exclude them from moral consideration that we normally apply to conscious beings. That's a familiar issue. But there are more issues that are far less familiar to people that make the topic of machine consciousness extremely important. So how many people here have heard of the control problem? Okay, so the control problem, oh, now this is where things get grim. Sorry. But so the control problem is the problem of how we would control artificial intelligence that is developed and becomes smarter than us. So think about the development of artificial general intelligence. Suppose that we get intelligent systems that rival or even exceed human thinking in certain domains and seem to have this general purpose ability to move flexibly from one domain to the next. So as my dissertation supervisor, Jerry Fodor, used to put it, an AI that can make breakfast without burning the house down. We don't have that right now, okay? But I suspect that we will need that as we develop androids to, say, take care of the elderly in Japan, right? So suppose we get an impressive AGI system. Well, shortly thereafter, according to individuals like Nick Bostrom, Elon Musk, Stephen Hawking, we will then get superhuman AI that's smarter than us in various ways, and eventually AI will be smarter than us in every way we can conceive of, and then that will be called super intelligent AI. So the control problem is the problem of how we would control an AI that is by definition smarter than us. Now the control problem arises for both the case of conscious and non-conscious AI. But military leaders worry, could consciousness make things worse, making the AI somehow more volatile? Think of a teenager in the throes of hormones, for example. My own view is that we actually need to not make any assumptions about what consciousness would do to AI. First of all, depends on the architectural environment. Consciousness in the domain of one architecture could make the system more volatile, and in the context of another architecture, it could make it safer. Think about the animal rights movement. To the extent that humans care about the suffering of non-human animals, it's because they're conscious beings. It's because we have consciousness that we are concerned with the suffering of non-human animals. Similarly, consciousness could save us. If there's a vastly smarter AI, the intellectual gap between us and them could be like the intellectual gap between you and your cat. And it may just be the fact that the AI is conscious that makes for a solution to the control problem. So that's what I tell the military. I work with them a lot on this issue. Other reasons why machine consciousness is important. I love this quotation. Richard Dawkins, always so quotable, says, "It's not obvious to me that a replacement of our species by our own technological creations would necessarily be a bad thing." I wish I could pin down his accent. But that's so suggestive. Yes, it's not obvious, but let's think about this, because if it's the case that non-conscious machines supplant biological intelligences, the singularity would be a complete nightmare. It would be the end of consciousness on Earth. But you might say, well, what if instead we slowly merge with machines? To go back to the issue of enhancement of the mind and the Jetson's fallacy. And in this way, we become one with artificial intelligence, as people like Elon Musk and Ray Kurzweil propose. Well, if AI isn't conscious, merging with machines would be a really bad idea. And neural prosthetics, they won't work right, at least when they get into the areas of the brain that underlie conscious experience. Okay, so that's my little spiel on why the issue is important, and it goes well beyond the robo-rights issues that if you go to the AI conferences, you'll hear about. Consciousness is important for a lot of reasons over and above the issue of robo-rights, which is of course very important. But I think there are future of humanity issues here. Okay, all this being said, I wanted to say a little bit about my work with NASA. And if you're interested in this, there's actually a show where I'm lecturing on PBS on my work with NASA, which is kind of cool because I'm just a geek at heart and I love working with NASA. So if you take my ideas about the import of machine consciousness seriously, and you ask what the evolution of intelligence could look like on other planets, on the assumption that there is life on other planets, and that these planetary civilizations survive long enough to develop artificial intelligence, it may be that they too are enhancing their brains and merging with AIs. Or it may be that AIs fully supplant them in one of these Nick Bostrom-like scenarios. Well, if that's the case, the issues of machine consciousness that I've raised take on a cosmic import. They speak to the evolution of conscious life throughout the larger universe. It could be that consciousness is a momentary flowering in a larger universe that goes out as civilizations become more and more intelligent. So we need to think this issue through carefully. We can't control the outcome on other planets, but we can control how things play out here. Well, maybe we can. I'd like to think through public dialogue we can make a difference. So now let's ask, will artificial intelligence be conscious? Well, in chapter 3 of my book, I write that machine consciousness, if it ever exists, may not be found in the robots that tug at our heartstrings, like R2-D2. It may instead reside in some unsexy server farm in the basement of a computer science building at MIT. Or maybe it will exist in some top secret lab somewhere and it gets snuffed out because it's too dangerous or simply too inefficient. That may have happened. Who knows? We don't know. It may even depend on something as unpredictable as the whims of a single AI designer, like Anthony Hopkins' character in Westworld. Okay? So I call my approach the wait and see approach. I need a better name. I need a jazzy name. Please, somebody help me. This is a middle of the road position concerning the prospects for conscious machines. One that draws from computationalism about the brain, but which stops short of a view I call techno-optimism. So you've heard some techno-optimists yesterday. I take Max to be a techno-optimist, and I also take Stephen Wolfram to be a techno-optimist, and we were kind of arguing about that. Well, techno-optimism about machine consciousness says that consciousness is an inevitable outgrowth of highly sophisticated computation. And of course, this seems to be the view of Ray Kurzweil in his intriguing books, as well as individuals like Elon Musk, Stephen Hawking, Michio Kaku. It's all over the news. But I think we need to think twice about it. We need to be careful. I used to think that the problem of AI consciousness did have an easy solution and that the techno-optimists were correct. Cognitive science holds that the brain is an information processing system and that all mental functions are computations. Given this, it would seem that AIs can be conscious, for AIs have the same kinds of minds as we do, computational ones. Just as a text message and a voice message can convey the same information, so too both brains and sophisticated AIs can be conscious. This is actually the dogma in my field, and I even wrote a book on the computational nature of the brain earlier in my career, where I pushed a position like this in a few pages. Luckily, I didn't push it in the whole book, but I definitely felt sympathetic. But I now think that machine consciousness is an open question for several reasons. So let's look at 4 reasons. First off, outmoding consciousness. All right. It may be more efficient for a super intelligent AI or even other sorts of AGIs, artificial general intelligences, that aren't full-fledged super intelligences, to eliminate consciousness altogether. Think about how consciousness works in the human case. Think about how when you drive, nowadays, if you're a seasoned driver, you probably aren't that aware of the path you're taking. And you may even at various points say, gosh, did I just cross that bridge? I don't even remember it. I'm so dangerous. I do this all the time. I probably am dangerous as a driver, but there's a reason in the cognitive science literature for this. Consciousness is reserved for novel situations in which you're focusing. Consciousness is closely related to mental processes like working memory and attention. When something becomes highly familiar, it's relegated to non-conscious computations in the brain. Most of your mental processing involves non-conscious computations. The stuff, though, that involves novelty and requires slow, deliberative focus, that's online for you. Okay, now think about what a superintelligence is. It's supposed to be something that's an expert in every domain. It could have rapid-fire computations that range across an entire planet. The entire planet could be its computronium, if you will. It could have vast databases that span the entire internet. What would be novel to it? Requiring slow, deliberative focus. Why would it need serial mental processing of the sort that we have, involving working memory and attention? Why wouldn't it be vastly more efficient? As a superintelligence develops, it may make design decisions. It may just decide consciousness is simply too inefficient. So for all we know, the smartest AIs may not even be conscious. My cynicism also militates me toward another reason, which is that AI companies may simply cheap out on consciousness, okay? So the properties that give rise to sophisticated information processing and which AI developers care about, they may not be the same properties that yield consciousness. Think about how AlphaGo, it beat the world Go champion. Think about Watson that beat the world Jeopardy champion. The algorithms utilized are not like the way your brain processes, even if you're an expert, when you play Go or Jeopardy. The way that these systems were able to excel was not brain-like. I mean, you might say, well, deep learning systems, in the case of AlphaGo, it was a deep learning system. It's brain-like. Well, not very much, right? And the heuristics utilized were not the same, okay? So similarly, why should we assume that an AI that is smarter than us also has conscious processing? In fact, AI companies may not care to even bother to go the next step and build conscious machines. What they're going to care about is something that functions intelligently. More cynicism. PR nightmares, that's another consideration. So I mentioned the robo-rights issue. Well, developing a conscious system could lead to accusations of robot slavery and other public relations nightmares, including demands to ban the use of conscious AI in the very areas that the AI was developed to be used in. So why create a project like that the public may not even let you use? If you're an AI developer, you might engage in what I call consciousness engineering. That is, developing certain architectures that are deliberately not conscious ones, because those machines would be treated unethically if utilized. So don't create the ethical muddle. Instead, deliberately engineer machines that are not conscious beings to serve us. Okay, finally, people don't realize that silicon's out, and we don't know what the ultimate substrate for artificial intelligence is going to look like. Right now, hot new microchip types involve graphene and carbon nanotubes, and we don't know how things are going to play out in 10 or 20 years. We don't know the trajectory for quantum computing. There's a whole list of unknowns when it comes to computing. So how can we tell if a substrate will actually be the right stuff to underwrite conscious experience? Okay, all this being said, there are reasons why we might expect humans to care to engineer consciousness into machines. So remember, I have a wait-and-see approach. I say, depends on the context in which the conscious machine is developed. I mean, it may be that some machines will be conscious while others will not be. I'm not arguing machine consciousness is impossible, okay? So there are some reasons why AI companies might care to develop conscious machines. First of all, maybe members of the public will demand conscious AI companions for relationships. maybe people will understand that if they're in a relationship with an artificial intelligence, which will inevitably happen, I mean, they're making these human-like androids. I was just on television with Sophia. Ugh. So, it may be that members of the public say, well, I don't want to be in a relationship with this creature because it doesn't feel like anything to be her. So then all of a sudden, the AI developers decide, all right, we'll make these conscious. Right? Situations like this are depicted in science fiction all the time. Another reason is that machine consciousness could aid in AI safety. But I think the deepest and most important reason is actually the domain of neuroprosthetics, because there's already clinical trials going on to replace or augment, well, I shouldn't say augment, what I should say is there are neuroprosthetics in areas of the brain such as the thalamus and claustrum. These are areas of the brain which are also implicated as being part of the neural basis of consciousness. So if we find that there are radical deficits in consciousness as these prosthetics are developed, that will need to be fixed, if it can be, okay? So I think there will be demand for developing the right sort of microchips that give rise to consciousness in the domain of brain therapies and enhancements, all right? But that's not to say that these technologies will succeed. We don't know. So furthermore, more reasons why machine consciousness might be possible. You might be in a simulation right now, in which case you are a conscious machine. Uploading could be developed, but uploading is so far into the future that we need to focus on the here and now, or at least issues coming down the pipeline in the next 10 to 20 to 30 years, not fixate on brain uploading. Finally, I'd also like to stress that there are sociological issues here, that we just cannot determine, like how they're going to play out. I mean, Westworld depicts these issues well in that sense, that personalities of the AI designers could actually impact whether conscious machines are built. Okay, so all of this militates for the wait and see approach. Now, how much time do I have?
So the session is until 11:15. We can go a few minutes longer, so that means you have plenty.
I'm good?
Even if we stop on time, we have
okay, good.
40 minutes.
Okay, so another reason why you might find conscious, deliberate AI projects that are designing conscious machines is for interstellar travel. So it may be that some benevolent individuals want to see the universe with sentience because they find that all those exoplanets that we think are inhabited are not inhabited. And there's a big question right now in astrobiology about whether all these habitable planets actually are inhabited. So you might say, well, that's speculative, Susan. Yeah, but I'm on the project. So we're over at the Institute. Several of us are writing a joint paper precisely on this in the context of Project Starshot. So Breakthrough Starshot is this exciting space mission to send ships, very tiny little credit card-sized ships, to Alpha Centauri at 20% of the speed of light, and they will have microchips on them. And so we're talking about collective intelligence and all kinds of fun things, and seeding the universe with sentience. And we're talking about it theoretically because it's exciting to discuss. And I wouldn't be surprised if at some point in human technology something like this is actually pursued if we find out that the universe is empty. The upshot of all this, the import of machine consciousness goes well beyond familiar robo-rights issues, and we need to know whether AI will be conscious. So, how do we test for consciousness? There's no neuroanatomy in an AI, and there's that notorious black box issue with deep learning systems that is pretty daunting. I mean, if we can't tell what AlphaGo did when it made certain really intriguing moves, you can bet that it would be very difficult to look under the hood of a deep learning system and determine whether it had an architecture supporting consciousness. So all this has led me to develop a few provisional tests. Okay, so the first test is something we just wrote up in Scientific American. It was, my co-author is Edwin Turner, an astrophysicist and exoplanet whiz over at the Institute for Advanced Studies. And notice, I guess the test is predicated on the following idea. Notice that nearly every adult can quickly and readily grasp notions based on the felt quality of consciousness. Okay? So, for example, consider the film Freaky Friday, where the teenager traded bodies with her mother. Okay? You didn't have, if you saw the film, you didn't have trouble understanding the premise because you're a conscious being and you get the idea, at least, you know, in principle, that your mind can be elsewhere. And of course, if you have religious beliefs, you believe this, but people who don't can understand the idea, at least in broad strokes, of reincarnation, out-of-body experiences, surviving the death of the body because you have something like a soul. So all of these things are concepts we get because we're minded beings. So the idea here is to test AIs to see if it grasps such notions. So think about it. The death of the mind of the fictional HAL system in Stanley Kubrick's brilliant film 2001, A Space Odyssey, provides a great example. HAL neither looks nor sounds like a human being, but nevertheless, the content of what HAL says as it's deactivated conveys a powerful message that HAL is a conscious being. It's one of the best scenes in film, right? So there are objections that I want to raise here. So one is, look at that Hanson Robotics android Sophia. You can ask Sophia if she's conscious, and they've already spoon-fed her answers, right? So you can imagine AIs of the future convincingly answering that they understand the concept of reincarnation and the film Freaky Friday, and they could even articulate the problem of AI consciousness and say they wonder if we are conscious, being made of a different substrate. Could get really interesting and persuasive. So how do you get around this fact? Because it could be that the reason that the AI indicates that it understands consciousness has nothing to do with what's going on inside of them from a conscious standpoint, right? They could have been programmed, or they could have had data fed into, you know, the neural networks such that they make the right responses. And the answer goes back to a cybersecurity technique that's discussed in the superintelligence literature involving boxing in the AI, okay? So what you do when you box in an artificial intelligence is you deny it access to the internet, and in this context, you deny it access to facts about human consciousness, about neurophysiology. You don't give it any information that could enable it to make inferences about consciousness, because after all, it may understand that if it acts conscious, it would have rights, okay? So you have to box in the AI, but that's not that strange, because after all, at the R&D stage, this is routinely done. You don't just unleash an artificial intelligence in the world, you develop it carefully in the lab. So notice that this test doesn't require looking into the black box of the AI, and it doesn't require a verdict on the neural basis of consciousness in humans. So the test is good in that way, because it doesn't require solving these extraordinarily difficult issues. All that being said, I just present the test as a sufficient condition for machine consciousness only. I don't think it's appropriate to run the tests in all cases. For example, an AI may not have a self-concept. I actually have views on whether AI would, based on cybersecurity issues, but I can talk about those in the Q&A if you want. But I think that not every AI would have the linguistic capacity, for example. I mean, this test is the kind of test you would run on a very sophisticated AI. So that's why I suggest that this shouldn't be regarded as something that's necessary for a machine to pass to be regarded as a conscious system. Instead, it is what we call a sufficient condition. It's enough if a system indicates that it's conscious in this kind of question and answer format, it should be extended legal protections. But that's not to say that if it fails, we should regard it as not being a conscious system. There are other tests as well. So, in a recent TED Talk, I introduced a chip test. And this test goes back to the issue of neural prosthetics. So, as neural prosthetics are developed in humans, as I mentioned, we will need them to underlie conscious experience if we're going to use them to replace parts of the brain that are responsible for consciousness. So suppose you have a chip put into an area of the brain that's responsible for consciousness, and then you say, to the physician as they check you, something doesn't seem right. I just say, lost part of my visual field. Say it was in a visual area. The test would need, the engineers developing the chip would need to go back to the drawing board, and they would need to fix the neural prosthetic so that it did support conscious experience. Suppose they tried this, and 20 years later, they still haven't got it right. And they've tried a number of different substrates. If that happens, then I think we have reason to believe that these chips of different types that we try do not offer the right sort of stuff to underlie conscious experience. But what if the chips succeed? In that case, we have a sense that, hey, in some architectural environments at least, namely the human one, what happens is these chips underlie conscious experience. So what do we do then in the context of artificial intelligence? If an AI in question is constructed from chips of that sort, I say that they have an important marker for consciousness, and we need to treat them with great care because they could be conscious for all we know. But remember, just because a machine is built of these chips does not mean that its architecture supports consciousness. Consciousness is not just a matter of a chip substrate, it's a matter of the entire architecture of the machine, right? This goes back to my point about outmoding consciousness, right? I mean, some architectural decisions that a machine makes or a designer makes may lead a machine to be not conscious at all. So we do need to go back to the ACT test, okay, in those cases. There are other tests also under development. I don't have time to talk about them today, but I mean, one influential test is Tononi's integrated information theory. And I could talk about that in Q&A. I'm skeptical about it though, but the great thing, this is a test that looks for a level of integrated information in a system. It's unfortunately not something that is easy to run. It's computationally intractable for anything, that goes beyond the size of a microchip, for instance, and there are other problems with it as well. But what I suggest is that there be a kind of provisional approach where a lot of different tests are used to check the results of each other in as much as possible. So in that way, we can kind of get a handle on the machine consciousness issue. Do I need to?
No.
Okay, so it seems like I've been speaking for a while. Okay, so that's my chip test. So now let me wind up. Okay, so soon, unenhanced humans may no longer be the most intelligent beings on the planet. And perhaps the greatest alien intelligences, if they exist at all, will not be biological, but what we call in the astrobiology literature, post-biological. Well, there will be a question about whether these AIs are conscious or not. I've stressed that the import of machine consciousness goes well beyond the issue of robo-rights, although that issue is important. It pertains to the future of conscious life here and even elsewhere in the cosmos. So I've offered what I call a wait-and-see approach to machine consciousness, stressing that some architectures could be conscious while others may not be, and you have to look at the incentives of the particular AI companies and even the architectural decisions that a superintelligence might actually make for itself as it begins to modify its structure through recursive self-improvement algorithms. I've also offered some very provisional tests. They have drawbacks, clearly, and I hope I've raised some of those drawbacks, but I think the ethical import of these issues is very much in favor of moving forward, hitting the ground running by developing tests for machine consciousness. Thank you.